On this problem, we're asked to complete this truth table, and I've given some definitions over here. So this tilde p is the negation of p. That's kind of like the opposite of p. This with the arrow is if p then q. So if p is true, then q is true also. And then this is negation of p, and this is an or statement. The one that's upside down of that is an and statement. So negation of p or q is true. Okay, so we're given this, we're given the p when it's true and when it's not true. So let's start filling out these columns. So let me zoom in a little here. Okay, so for the first one, it says if p, then q. Okay, so if p is true, then q is true as well. Is that true here? Well, yes, p is true and then q is true. So that one is true. Okay, the next one says if p is true and then q is false, but we want it to be if p is true, then q is also true. So this is false. Okay, so this is not the statement of p then q. Okay, now for this one, we're starting out with the statement that p is false and q is true, which we know nothing about with this statement. So we'll just say that that is true because we have nothing to say that it's not true. So we'll say, well, that one is true. That one doesn't conflict with the statement if p then q. Okay, so we'll call if p then q true on that. Okay, now for the next one, we have the negation of p, okay, which is the opposite of p basically. So this one is very easy to fill out. If we've got p already and we're asked to fill out the opposite of p, you just write down the opposite of this column right here. Okay, so on the first two, p is true, so we'll put false on both of these. And on the second two, it's false, so we'll put true on both of these. Okay, now for that last column, 5, we have the negation of p or q. Negation of p or q, which means what you're being asked here is either one of these true? Okay, so if the negation of p is true, then you automatically put a true there. If q is true, you automatically put a q there. Okay, so let's go first look at negation of p, which we've already got. So we've got these two are true. So since this is an or statement, it's saying is this or this true, or both maybe. Okay, so since that is the case, then we can go ahead and put true there because the negation of p is true. So that fills up those two. Now we got to look at these two because here the negation of p is false. So we need to look over here. Well, okay, well, is q true there? Okay, and q is true here. So I'll write down a true there. But in this box, we have that the negation of p is false, and we have that q is false. So both the negation of p and q are both false there, so neither one of them are true, so we have to put a false there. Okay, so the next question that you might get asked on this problem is which two of these are equivalent? Which two columns are equivalent? Okay, so we can look at these two columns and we can see that these two right here are exactly the same. Those are equivalent columns. Okay, so we'll say p then q and negation of p or q are equivalent. Okay, so these two are equivalent statements. Okay, so on the next question on this problem, it says that you want to find something that is logically equivalent. Okay, find something logically equivalent to the following two statements. 2 plus 3 is not equal to 5. Okay, that's a negation statement. Okay, and then 4 plus 6 is equal to 10. So this is a negation statement, so you might think of this as being that, and you might label this 4 plus 6 as being q. Okay, So this is, and I forgot to put the or here. So you can think of this 2 plus 3 as being a negation statement. So negate p, or, which is this, 4 plus 6 equals 10. We can call that q. That's not a 9, that's a q. I'll put a little tail there. Okay, so you can think of this as being the negation of p or q. Okay, and we've just wrote down right here what the equivalent to negation of p or q is. It's p then q. So we're looking for p then q. So if this is the negation of p, then what is p? Okay, well that's just 2 plus 3 equals 5. If the negation of p is equal to this, then this is p. Okay, and we also know what q is. That's unchanged. So q, what is q? Well, that is 4 plus 6 equals 10. Okay, so if we're looking for an equivalent statement to this, and we know that this is true, we're looking for this, p then q. So we would have 2 plus 3 equals 5, and then 4 plus 6 equals 10. Okay, that's p then q. And that's it.